A good portion of the science work that's being done on the International Space Station is coming here through universities or government agencies, but not all of it. For instance, there are drug companies that are using the weightless environment on the space station to improve their products. My colleague Lori Meggs at the Marshall Space Flight Center in Huntsville, Alabama, recently spoke with a representative of Eli Lilly and Company, which has been in business since 1876, to find out how that company is utilizing the world's laboratory on orbit.
Let's talk about Eli Lilly's involvement with the space station. That's quite a combination.
Yeah. We've got 4 experiments going up at the end of 2015 and into 2016. And they're really looking at very different things. So we set ourselves up for a number of different experiments to learn different things, and if something didn't work out, that would be fine.
What are we looking at?
First experiment is looking at a investigated product. We're looking at a new molecule that has some very interesting properties in muscle wasting, and it counters muscle wasting diseases. So it's of interest to us, and it's of interest to NASA. The second experiment is looking at crystallization. It's actually 2 sets of experiments. The first is looking at co-crystallizing proteins of interest with molecules that we're working on to see how they fit together, getting crystals of those. And the other is looking at hard to crystallize proteins, mostly cell surface proteins. The third experiment is looking at freeze drying. Lyophilization is what the technical term. But when you take a large batch of material and you freeze dry it, it tends to layer out like a cake. And those different layers represent different forms of the same material, crystals or powders, and that's a bad thing for us because we want everything to be uniform, especially if it's drug product. So we want to understand where that layering is occurring. Is it happening when it freezes, or is it happening when it gets dried? So we're actually going to make a big batch of material, and we're going to freeze dry some of it on Earth, and then we're going to freeze dry some of it in space, and then we're going to freeze some of it on Earth and dry it in space, and freeze some of it in space and dry it on Earth. And logistically, that is the most difficult one, because the last experiment where we freeze it in space and then drop it out of orbit and then bring it back, we have to have a facility nearby that we can drive it to and dry it in while it's still frozen.
Wow.
So that's going to happen in San Diego, one of our sites in San Diego. And then the last experiment, which was supposedly the easiest one to execute, we thought, the simplest, is a mixing experiment. We're taking a liquid, a solid, and a gas, and we're mixing them together. When we take a mixture of material like that on Earth, we can watch how it dissolves, and there tends to be an issue associated with how much material floats. That has an impact on how well it dissolves or how fast it dissolves. And that's called the float effect, and we're trying to counter that by putting it in an environment where there is no float and see what the impact is. That experiment we thought would be the easiest, just mixing up a bunch of stuff, but it is technically extremely challenging. How do you measure it? How do you get the liquid in there once everything else is in there? How do you mix it consistently?
Space isn't easy, is it?
Space is not easy, no. They're all designed to have some impact or lead to better understanding for us and how we do some of the things that are basic, fundamental things that we do in our labs. At the same time, some of them are more specific to certain situations, but again, they're built to teach us something about what we think we know. People who work at the company, the people who are involved in a lot of these experiments are scientists, chemists, biologists, what have you. But these efforts with NASA really forced us to have conversations that many of us have not had since we were undergraduates, about basic science or how we think things will happen. And it's oftentimes the most powerful experiments are the simple ones where you pretty much know what to expect, and it doesn't happen that way, right? It makes you fundamentally think about what you're doing and why things happen.